So first, what you have to know, it is a DC machines means what type of device it is? It is a electromechanical device. So conversions of some form of energy to something. Okay. So it has to convert either from mechanical energy to a DC. Since it is a DC machine, it will convert into a DC current, that is direct current machine. Okay. Or else, if we are giving a DC supply, it will be converted into a mechanical energy. Either two modes of conversion. If suppose DC current is given as input, mechanical energy is generated as output. What is that? It is what is the application over that? Motors. Okay. What we are giving when you are switching on it? What is giving? We are giving a supply to it. Okay. If it is a DC machine, we will be giving what does it mean? We are giving a direct current to it. Okay. In industries, these things will be applied. In industries, the operation should be happen in a continuous manner. Okay. So in our home, whenever we require that motor to be in on condition, we will be on that, and for our safety purpose, we are going for an AC machine. Okay. In industry, it is a high powered direct current machines. In our some factories or what's happening, a frequent of operation, one batch by batch, the continuous operation takes place. For that purposes, DC is adopted. Okay. So what is happening? If you are giving a DC current as an input, so it will convert it into a mechanical energy. Okay. So if DC current is given as input, if it is converted to mechanical energy means what it is mean? It is generator. Okay. So that is it is generating what? Electrical energy. Okay. So two things of conversion. If DC supply is given, mechanical energy is generated means it is motor. If mechanical energy is given, DC current is generated means it is what? It is generator. Okay. So whereas you can see the generator. So two things. One DC machine as motor, and the other one is the DC generator. Okay. So DC motor, what does it doing? It converts. We are giving electricity or in form of direct current. Okay, it converts into what? It converts into mechanical energy. Which means the motor is rotating. Okay, it converts into mechanical energy. This is a DC motor. And if suppose mechanical energy is given as an input. Okay. And if direct current is generated, then it is said to be what? Generator. Okay, that's it. This is the basic about DC machines. Two machines. One is DC generator, another one is DC motor. You just remember the DC motor which is available in the industry. That is whenever the DC current is given, mechanical energy is generated. Okay. And if suppose mechanical energy is given means DC current is generated. Okay, that is comes under the generator station. Okay, and after that, just you have to know the constructions and all that. Okay. So this is how your constructions of DC machine. That is, the construction may be similar. Okay, the construction may be similar for both the DC motor as well as DC generator, and based on its design, it will vary in particular cases, like based on the windings. Okay, based on the end of the windings, how it is connected, it may vary as lap winding or wave winding, something like that, and that I will tell you later. But construction will be similar for both DC motor and DC generator. Okay, so this is how the construction will be for a DC machine. Okay, then outside that is all we will calling it as a frame, or we can say that as yoke. Okay, and this is a hard core. Okay, and it is made up of a high permeability material which can stand up. You can see that machines, right? It is made up of, it is very hard to touch it. When you are touching it, it is very hard. Okay, so it is not easily breakable. So the outer surface, that is outer peripheral, is said to be frame, or we can say it as yoke. Okay, and inside there is a whole core. It is N over here, and yes, these are said to be whole cores. And if the pole goes, who is having means here is a winding I made it, right? This form of design. This is the winding, and this is the field coil. This is said to be what? Field coils. Okay, all these constructions important. This is what said to be what? Field coils, which is present in all the four pole cores. Okay, and next inside there is a armature conductor. Inside there is what? Armature conductor, or mounted, which means armature windings. Okay, inside there is an armature conductor which is having armature, which will be having both the armature core as well as there will be winding. Whenever you see a motor or a machine, we used to say that coil is gone, right? Coil is repaired. We has to change the coil after. That coil is what? It's a windings. It's made up of copper wires. Okay. This armature core will be having the armature core. There is an armature conductor which is wounded with a copper wire, and that is said to be armature windings. Okay. And in the center part there is a shaft, which where we can able to, whenever you are doing in machine lab, you will be doing DC shunt motor as well as DC series motor, and there you will be measuring the speed of the machines, and in center part only you will be holding the tachometer. Tachometer is what? For measuring the speed. You will be using a device that is said to be tachometer, and you will be placing that in the center part of the rotating machine. Okay, in the rotating machine there is a center part that is said to be what? Shaft. Okay, and next, that's all the overall parts of the DC machines. An outer surface is said to be what? Yoke or else frame, and this is the hard core. It is made up of a high permeability materials. Okay, and after that, this side that is having a 4 pole cores. Okay, and then they are wounded with what? Field coil, and in the central part there is an armature core, and it is wounded with whom? Copper wire, and that it is armature windings, and in the most central part is the shaft, and this is the construction details of the DC machines. And under that each heading you will be writing what it is. Yoke. Yoke is, as I said, you will be writing it as yoke is a high. It is a hard core which is made up of a high permeability membrane. It is mechanically strong. Okay, and after that, what is the purpose of this yoke means? It will protect the internal machine parts. There is multiple parts which is present inside the yoke, right? And this will, the outer core, if it is strong means only the internal parts will be safe. So what is the purpose of yoke to be strong? It protects the internal parts of the machine. And next it will hold the entire magnetic field. What is going to happen? If it is a motor means what is happening? If we are giving a DC current, it will convert it into a mechanical energy. That type of conversion, what will be generated? Magnetic field will be generated. Then only conversion might be had. Some work has to be done, right? Some working should be done inside the machine for the conversions of energy. So that will be kept safe by who? Means the outer peripheral region, that is the yoke. Okay. So next one is, it supports all the inner construction, rotor, armature, and 2 more parts will be there inside the DC machines. That is we will be saying it as commutator, and brushes, bearings will all be there present. Okay, that is commutator, brushes, and bearings will also comes under the construction. Will also comes in the constructions of the DC machines. Okay, and next, by putting the side heading, you will be writing all these things. You must know first what is this constructions and what it is made up of. And next one is armature. Armature is, as I said, what it is. It has both the conductors as well as it is wound with what? Copper wire. That is said to be what? Armature windings. Okay. So after that, and this why this armature winding, what it is doing means it is developing the torque as well as EMF. What it is, the outer core is doing? It is safeguarding the magnetic field which is generated during the conversion. And what is this armature doing? Developing the torque as well as EMF. Whenever an electrical input DC is given, some torque is generated, right? Some speed, motor will start to rotate. If it start to rotate means automatically who plays the role? The torque comes. So what is happening? It's torque as well as EMF. EMF is what? Electromotive force. Okay, so we are giving some electrical energy, some force is being created, some rotational force, motive force. So that is all comes under who? That armature, that is by who means by the armature winding. Okay, and next the two main parts of the armature winding. As I said, it is armature core as well as armature winding. And what is this armature core made up of? Armature core means you are seeing around there is a small balls like structure, right? That is armature core. What it is made up of means it is made up of a solid cylindrical structure. How it is? It is a solid particle which is hardest. It is a solid particle and it is also made up of high permeability material. It should withstand whatever force may be given. Okay, it is also highly permeable. And when we are seeing the armature, it is molded with, or we can say that it is laminated with stainless steel. Okay, you can, in small machines you might have noticed that some silver, for it is stainless steel, but for your known I am saying that some silver with small balls. Have you ever noticed in some sort of toy machine, something like that? In bearings. Okay, you can notice that, right? So in machines it will be in a larger size. Okay, that's it. Okay, the stainless steel laminations has been done in the armature core. Okay, and next it is the armature winding. As I said, it is made up of what? The windings which is wounded in the armature core, and that it is made up of copper wire. Okay, so based on the ends of the, if suppose we are doing the windings, right? So one end, we start with one end and the winding has been done, and the other end will be there, right? Based on this constructions of the winding, based on the two ends of the connection, it is divided as two constructions. One will be saying as lap winding and other will be saying it as wave winding. You all clear? Winding means there will be what? Two ends, right? Copper wire only. If we have done the windings, remaining the two ends will be there, right? Based on that, two constructions has been done. One is said to be the lap winding, and the other one is said to be wave winding. Okay, what it is the lap winding? The wave winding means, so if suppose these two ends, okay, if it is connected to another, the next set. If it is connected parallel means that it's said to be lap winding. Okay, for example, here it is. For example, here is north, south, 2, right? So it will be like this. If it is like this way, first to the north, south, again north. So just so you know north and south. Okay. So if it is done like this. The same point. Okay, so if it is connected from the same point, okay, so it is in, how we can say that the connection is in parallel. Okay, so if it is like this, that is to north, south, again to north and south. Okay, one after the other, like the hexagonal shape. Okay, which is connected individually, again which is connected individually. If it is connected in series, okay, one after the other. Okay, if both the ends are connected parallel means we'll be saying it in lap winding. Okay, you no need to draw that, just you know. This lap winding means what? The ends are connected in how? Parallel. Okay, and the if it is connected in series means that winding is said to be the wave winding. These are the constructions of the armature winding. Okay, and next what you have to know is field system. What is as I said, what is doing the field system means it will produces the magnetic field. Okay, that is field system. What it is doing? It is producing the magnetic field. Whenever some input, the direct current is given to the DC motor, what it has to do? It has to convert into some sort of energy. So what is going to happen inside? Some magnetic field is going to generated. That magnetic field is produced by who? Field winding. Okay, so each construction, each part has to do some work, okay, in the machines. So you have to mention that constructions, what you have to draw the diagram, then what are the parts of it, and each parts performing what function, that you have to describe. That's it. Okay, so field winding, what it is doing? It is producing magnetic field. Okay, so it is the stationary part of the machine. The field winding will not the field winding, it is stationary in nature. Okay, it will not change, or it is fixed in nature. Okay, and this field winding is fixed to whom? When you are seeing that diagram, the field winding is fixed with what? The field winding is fixed with yoke, right? The outer core. So it is fixed with machine. It is the outer structure, that is outer yoke of the machine. Okay, and next is the it has three main parts. The field winding has three main parts, and we can say that one is, what is the field winding connected with field winding? What are they? Pole. So three main parts. One, it is the pole core, and in between the, so I have drawn here something, right? What it is? Pole core. Okay, I have drawn here pole core it is, and this is pole shoes. Okay, and that is what? Pole shoes. Three main parts of the field winding. One it is what? Pole core, and other is pole shoe, and other one is what it is there in the pole core? Field coils. These are the three part of the field winding. Okay, what it is in field system? What are the three parts? One is pole core, another one is pole shoe, and the other one is pole coils. Okay. So these are the things you have to describe in the constructions of the DC machine. Clear?